So good afternoon. Hi, should I say, there's only one lady out there, so two ladies. So good afternoon, ladies and gentlemen. I hope you had good lunch. I mean, so we'll have to ensure that like you're not falling asleep. So with that said, myself, I am Sesha Sai Kandrakota. I'm a managing director in Accenture. I lead the energy practice globally for the strategy and consulting and global network. And I've been in the industry for about 30 years. This is my 31st year. So right now we are going to talk about something which is very interesting and close to my heart, which is about supply chain logistics execution and operations excellence, leveraging AI, ML, data, big data analytics, advanced analytics, and all this stuff. So I have four esteemed guests out here who have done some stellar job. So I'm going to introduce one after another, and they are going to come and touch upon the topics of what they have presented, what they have done, what they have executed in their respective organizations. So, so with that, I would want to go with the first um, dignitary of our afternoon, which is Shitanshuji. So he is a DGM, Information Infrastructure Services at HPCL, accompanied by his colleague, young and dynamic Vishal. And Shitanshuji comes with about a couple of decades of experience in the IT industry, in the IT and operations, projects, quality, infrastructure, information security, and all. So post his BTech, he had multiple postgraduate degrees from Mumbai, from Andhra University, from BITS Pilani. So quite a few things. It's an interesting journey of his. They have done some fantastic work in HPCL, completely revamped the security infrastructure with state-of-art solutions enabled with AI and ML. And they have implemented a next-gen security operations center for monitoring, detecting, preventing, and mitigating the cyber attacks, which is one of the key problems which you are facing in this particular industry of oil and gas. With that said, can I request Shitanshuji to just, and accompanied by Vishal. Thank you. Yeah.
Put up the presentation. Good afternoon, and thanks, Mr. Sheshasai, for the introduction. So, we are here to speak on a very core IT topic, uh, but it is of interest to everyone, and everyone is talking about it today. So, we are talking about cyber security. And when we are talking about cyber security in a critical infrastructure, which our energy sector comes in, uh, especially focusing on on-prem data center. As we know that today there is a proliferation of cloud services, but despite this rise of cloud applications, on-prem data centers still remains critical for us, for the critical industries especially like energy. It provides low latency, regulatory compliance, and full control over the data. So today, the warfare and rivalry among nations and corporates takes place in the cyber world. Cybersecurity has attained immense importance in the industry, especially critical energy sector like power, petroleum, etc. Nation state actors, threat actors, and APTs have been known to target DCS and ICS systems and SCADA systems. We also need to be vigilant about what we call as zero-day vulnerabilities, which keep coming every now and then. And to keep all these digital assets under protection, we focus on what we call in cybersecurity parlance as the CIA triad, the confidentiality, integrity, and availability. So focusing on that, we will proceed. So as the world relies more and more on digital technologies, not only for day-to-day operations, but also for various business functions like strategy, business growth, customer service, healthcare, R&D. Today, digital is everywhere. The complexity of, and with this, the complexity of computing systems and networks opens new attack surfaces. Cyber threats are continuously evolving, and organizations need to implement adaptive security measures. While industries grapple with the threat to cybersecurity, managements must appreciate the importance of adequate resource allocation to meet this challenge. And today I am sure managements are realizing this and providing sufficient budget to fight cyber threats, not only for cyber security technologies, but also for skilled manpower. Different assets have different levels of security. Hence, assets need to be given the required level of protection as per the risk associated with them. The protection can be physical, network, application security, and this multifaceted approach ensures that if one layer is compromised, the other layer is there to protect. We need to protect assets giving greatest importance to the innermost, what we call the crown jewels of the organization. Greater the risk to a class of assets, greater is the level of protection required, and we must prioritize accordingly. Basically, a layered security approach relies on the next layer, as I said. If the previous layer fails, it enhances the resilience. But it is not only solutions and devices, but also correct strategies, processes, and monitoring which enhance overall security. Behind that, there must be a competent team to manage the incident response, which can include prevention, detection, triaging, mitigation, forensics, etc. of cyber threats. And that is where a well-managed and well-equipped SOC comes into play. So, layered security is an age-old strategy borrowed from the world of warfare. So, if you see the old castles, how they were protected by moat, ramparts, fire-breathing dragons, and so on. Once the drawbridge is pulled up, it is protected. But after the drawbridge is lowered, if anybody enters, he has access to the entire area. This is what happens in cybersecurity also. If one intruder gets into the network, he can play havoc with anywhere and everywhere. And this is the model which was adopted initially in cybersecurity also. But with technology enabling both attackers and defenders, and also the fact that there is no more a fixed perimeter, like in the old castle, there was one castle and one perimeter protected by a moat. In IT now there is no fixed perimeter. Every endpoint is its own perimeter. So in that scenario, a new approach of defense in depth should go beyond that traditional approach of castle and moat. And we also need to take care of internal threats, which is also quite a significant one. So for ensuring a robust cyber security model, these are the three major areas we focus on. From the process point of view, you may have the best of devices and solutions, but unless they are configured and hardened with best practices, they are of no use. So hardening is regularly updating software, disabling unnecessary features, applying security patches, etc., to maintain system integrity. Application security becomes very important as most of the applications are web-enabled and vulnerable to attacks. Network segmentation is a preliminary requirement to segregate assets, to contain threats and attacks when they happen. So it actually isolates network segments on a real-time basis and protects from any threats, attacks which happen. So at HPCL, we have implemented the latest state-of-the-art solutions, creating a true defense in depth. So this is the layered security which we have tried to depict pictorially. So as we move from the innermost layer outwards, we have XDR, DLP. These are some jargon. Excuse me for using this jargon, but XDR, DLP, identity management, firewalls, honeypot, and so on, which protect the innermost crown jewels, the servers, and also the endpoints. Access to internal servers and applications are protected with proxy, WAF, VPN. Our WAN links are enabled with DDoS protection. And on the outer periphery, you can see various compliance and monitoring systems. AI, as we know, has evolved as a major game changer in many sectors, including cybersecurity. While attackers were early adopters of AI, we on the defense side cannot lag behind. Many solutions are being enabled with AI/ML to strengthen security. We have kept this in mind during our security revamp. Now we will briefly explain the various next generation solutions that we have implemented at HPCL, and I'll invite my colleague Vishal Kumar to take over from here to just briefly explain each of the solutions which makes the whole.
Thank you, sir. Yeah. So we have adopted many new solutions in our HPCL data center for protecting our crown jewels and other assets. First, we will start with the perimeter defense. Okay, start with our next generation firewall. Okay, we have adopted next generation firewall replacing the traditional firewall. Next generation firewall have an IPS feature. Apart from that, it has an anti-malware, anti-bot protection, which truly gives DPI, deep packet inspection capability, as well as whatever the behavioral patterns and other patterns which are available. Okay, you can stop those kind of traffic entering into your data center first. Apart from that, we have a URL filtering to block malicious and authorized accesses. So there are multi-layer of the security that is provided by these boxes, which is helping us to prevent the malicious traffic before entering into the data center. Also, when it comes to network segments, so we have multiple segments, okay, and each and every segment traffic crosses through these firewalls, so which gives more protection. Moving to that, okay, we have a web proxy. We all know that we are living in an interconnected world, okay, where every now and then people are connected to the internet, and without the internet we cannot survive. Neither the business can survive. To safeguard from the internet attacks, okay, so we have a web proxy, which is a cloud-based proxy. Apart from that, we have a private access also enabled. When it is in a private access, so we are just checking user as well as the device before authorizing the application. Okay. Once both user and devices have been given permission, then only our safeguarded data center application access is provided to the user. When it comes to the web proxy, we are using zero trust integration. We have DLP enabled also. So we have a full visibility what kind of the data that is leaking, and we have also policy-based prevention, whatever the confidential data that should not leak out. Apart from that, we are using remote browser isolation feature in our web proxy. Wherever this malicious or unknown sites they are being rendered, okay, so instead of rendering into your own laptop or workstation, they are being rendered in isolated environment where download and upload is prevented, so that you are safeguarded. So overall, this provides a shield users from malicious sites and DNS threats. We are also having DNS security enabled, so which helps in blocking DNS related and CNTSU communication. Okay, so overall user, whether they are on-premise or off-premise, they are safeguarded every time. Apart from that, email gateway, we have a very good solution that is also cloud-based. So one thing is that the benefit of the cloud-based gateway is, before entering into a data center, the traffic is getting cleaned at the gateway itself with the feature enabled. So first and foremost, this spam has reduced very much drastically. Apart from that, phishing and malware detection helps the user not to get phishing related emails, as well as whatever the attachments or the links that are malicious. Okay, so this is safeguarding the user, because we all know that, okay, our endpoint is in a very weakest link. if anyway we are getting some phishing or malicious content, okay, that may have a lateral movement and it may reach to our cron jewels also. So this is giving a good prevention. Uh, so overall, this reduces email-based breaches and improves organization security, and also it gives a confidence in the employees also, because they are getting the less headache from the spamming, and they can concentrate and focus on their work practices. Apart from that, we have honeypots. Okay, so honeypots are in the decoy, which try to lure the attackers, even though it is inside the data center, but these are the isolated system where we are genuinely exposing some of the vulnerability so that attacker can come. But through this honeypot system, we are just analyzing what are the activity that they are doing, so that we can get to know the intent, and based on their pattern and from where they are attacking. Okay, so we have an intelligence, and accordingly we are using those intelligence in our peripheral devices as a threat intel to blocking it. Apart from that, we have a next generation SIM solution coupled with SOAR and UBA. So here we are using the AI and ML capability of SOAR and UBA. UBA is giving a behavioral based threat pattern, which is helping us from the insider threat attacker, as well as the behavior pattern that any malicious activity is happening. Also, we are using SOAR, which is provided the orchestration and response layer, where whatever the mitigation action can be taken by individually the SOC analyst. Okay, so that can be better and faster. So it is reducing their time and overhead. Also, it is helping in reducing the false positive. So overall, when you are getting the logs from the different sources, okay, so analyzing is in a primary focus, but alert fatigue should not be there. So combining this solution, that gives a better visibility what is happening in your environment. Apart from that, we are having the XDR solution coupled with the EDR solution, which is helping us in giving a more visibility of the all endpoint and faster detection of the malicious activity. Apart from that, we can integrate these solutions with different kind of gateways and firewall, okay, which gives a visibility of all those endpoints and whatever is happening around, so that we can contain it properly. Since these are the AI-based and ML-based solution, okay, which gives a better protection in terms of the traditional system. So overall, this is enhancing our security posture. Apart from that, whatever the solution that you buy or implement, okay, so thing is that asset discovery is very much required, and their risk assessment is very much required, because accordingly that you can make a policy for your critical and non-critical system, and execution, whatever the best practices is being guided by the industry, that should be implemented. And post implementation, we have to do the regular update and fine tuning of the security system, because security is not always, you cannot say that, okay, we have achieved. Okay, it is an ongoing journey. So these are the benefits that we have already realized from our system. Last, I just want to recommend that this hybrid security integration very much required, because even though we are having an on-prem data center and there are devices inside the data center, but there are many cloud-based gateways and other solutions. Okay, coupled with, we can get a good security. Apart from that, agile threat response is very much required, because day in, day out, IOCs are there. And whatever the IOC that you are getting, it should spread across all the solutions, so that you have a better safeguarding. Apart from that, realistic cybersecurity expectation should be there, that you cannot achieve the ultimate security, and it is an ongoing process. So you have to think about your risk mitigation and vulnerability, how you can reduce your vulnerabilities, and the continuity of the operation can be achieved. Apart from that, collaboration with the industry partners is very much required. Right now, we are having partnered with Certain and NCIPC. They are not only providing the feedback of the IOC, but also they are taking our traffic. Okay, so if OMC can just brainstorm, okay, what are the solutions they are having, because they have the common problem, they can achieve the security in a better way. Thank you.
Thank you, Vishal. Thank you, Sitanshuji. So how many of people here are from refinery background? Thank you. So we have quite a few. So there is something which is pretty interesting for me. So I'm going to now invite Dhanush Parsa, who's hands-on on the refinery, crude distillations unit and hydrotreaters and coker, on the delayed coker, and of course he's also a digital champion. He is going to talk about one of my favorite topics, which is about pigging, and we working in the IT industry keep talking about AI ML. So how they have leveraged AI and ML in identifying the maintenance requirements and delayed coker unit, and pigging is something what Dhanush is going to talk about. Dhanush, over to you, please.
So, respected Chair, my fellow panelists and industry leaders, good afternoon, everyone. It is an absolute honor to be here today at India Energy Week 2025, sharing an innovation that is reshaping refineries' maintenance strategies. As oil and gas sector is accelerating its digital transformation journey, predictive maintenance has emerged as a game changer, enabling us to transition from reactive and scheduled maintenance towards a data-driven and proactive approach. So today, I'm excited to take you through a real-world implementation of this principle. That is how Bharat Petroleum has harnessed the capability of AI-driven predictive maintenance to optimize pigging frequency in delayed coker units. DCUs play a very vital role in residue upgrading, converting heavier hydrocarbons into valuable lighter hydrocarbons. However, a major challenge in DCU is coke buildup in heater coils, which is an inevitable byproduct of high temperature processing. The coke buildup causes reduction in heat transfer efficiency and increased pressure drops, elevated skin temperatures, which in turn raises fuel gas consumption and risk equipment damage. To resolve this, we follow a process, pigging process. It is a critical maintenance activity that cleans up heater coils and restores heat transfer efficiency. But here is the catch. Every pigging event requires a temporary shutdown, leading to production losses and increased operational cost. Traditionally, refiners follow a fixed pigging schedule, which often results in inefficiencies. Too frequent pigging wastes resources. Delayed pigging will have a reliability issues and energy inefficiency. So this brings us to our key question. Can we optimize pigging frequency in delayed coker units using real-time data and predictive analytics? So the answer is yes, that's exactly what we have achieved at Bharat Petroleum. While fixed pigging schedules have been the industry standard for decades, they do come with significant challenges. The primary issue lies in its assumption of uniform fouling rate across the heater passes, an assumption which rarely holds true in real-world applications. So for an example, the historical analysis of our own case revealed skin temperature differences of 25 to 30 degrees across the heater passes at the time of pigging. So to give a detailed explanation of this, at the time of pigging shutdown, if one or two passes of the heater is having the skin temperature of 640 degrees, other passes used to have a skin temperature of 610 to 615 degrees. So this is clearly indicating the uneven fouling rate in the passes in the same heater itself. So this inefficiency is resulting in premature pigging and underutilization of the coil potential and frequent shutdown startup cycles, which will raise the maintenance cost and which will also give operational disruptions. So to overcome these challenges, we needed a smarter approach, one that determines right time for the pigging based on real-time data and predictive analytics, rather than relying on rigid schedules. So, in response to the challenges that we are having in the traditional fixed pigging schedule, we set out to redefine ourselves by our maintenance strategies by applying cutting-edge technologies. So our goal was clear. We need to move away from fixed pigging schedules and adapt a data-driven approach that aligns with actual equipment conditions. So to achieve this, we have focused on a critical insight, that is coil skin temperature is the primary indicator of fouling. So building on this, we have developed advanced AI models trained on historical data of key process parameters to forecast coil skin temperature with an exceptional high accuracy. To translate these predictions by AI models into actionable insights, we have integrated all these models into DCS so that this will ensure real-time monitoring of the heater conditions, providing continuous insights on fouling progression. This will also ensure the pass flow adjustment of the heater based on the predicted fouling trends. So beyond optimization, this process represents a strategic shift in the DCU's maintenance philosophy, that is moving away from schedule-based approach towards a condition-based approach. So based on this transformative approach that we have discussed, the AI-driven solution introduces several game-changing capabilities that enhance operational excellence and decision-making in DCUs. The maximized coil extraction. By analyzing heater conditions, the pigging is planned only when it is required, so ensuring coils are utilized to their full potential. Then extended equipment life. Optimized pigging cycles will minimizes mechanical stresses on heater coils, thereby reducing wear and tear and increasing their overall lifespan. Energy savings. By adjusting pass flow rates and optimizing pigging schedules, fuel gas management will be very efficient, and this will increase energy efficiency and reduce the operational costs. And based on these AI models, we have also developed a web tool, scenario-based scenario analysis tool. This user-friendly tool will allow an engineer to simulate various operational scenarios to enhance overall system performance and proactively plan the pigging operation. So this solution is more than just an AI model. This is a system that will integrate predictive analytics, real-time monitoring, and scenario-based analysis to proactively plan the pigging operation. The implementation of this solution has delivered a measurable and impactful results for us. With accurate pigging predictions, we have been able to extend our operational uptime by 30 to 50% between the pigging cycles, reducing required maintenance shutdowns. With this, we are also in a position to eliminate 2 pigging cycles for every 3-4 years, reducing labor cost and maintenance resource allocation. Additionally, by minimizing unnecessary shutdowns, we have also eliminated flaring events and reduced high-pressure steam consumption, leading to significant cost reduction in energy and improved sustainability. So these results demonstrate the real-world impact of our AI-driven solution, that is reducing cost, minimizing downtime, and enhancing overall energy efficiency of the system. Beyond these operational improvements, the AI-driven solution offers broader benefits that extend across reliability, sustainability, scalability, and cost efficiency. These advantages position it as a transformative innovation for the DCU's ecosystem. The data-driven model is scalable across other DCUs and allowing its scalability across the different refinery networks. By reducing maintenance frequency, optimizing resource utilization, and improving operational uptime, this solution offers substantial annual cost savings for any refinery. To summarize, the solution delivers cost-efficient, scalable, and more sustainable advancement in DCO's maintenance. In conclusion, this solution offers a transformative step forward for the oil and gas sector, and it's a testament to how a data-driven innovation can redefine traditional practices, delivering smarter, more sustainable, and cost-efficient outcomes to the refineries. Thank you for your attention.
Thank you, Dhanush. That was awesome. And I think there is a lot to learn. I think I'll have to come down. Uh, the monitor AV team, the monitors on the dais aren't enough, so people are not able to figure out whether we are being heard or not. Yeah, this is good. Thank you. Let me now talk about Subhendu. So he works with BP, and he's a go-to person for anything you talk about artificial intelligence, machine learning, deep learning, and now he's playing with the Gen AI as well. And he brings them to life by conceptualizing, contextualizing, designing, developing, and deploying as well. So now he is going to talk about a story of real-time equipment monitoring solution. His co-presenter Yogesh couldn't make it for some reasons, so you'll have to bear with him for the whole of 15 minutes when he's going to talk. Subhendu, over to you for your talk.
Thank you. Thanks all. Okay, so my name is Subhendu. So today I'm going to talk about this, real-time equipment monitoring system that we developed at BP. So, so I'm Subhendu. Unfortunately, Yogesh and Pranav could not be here, so I'll be presenting for the whole duration. So here's a brief disclaimer I have to put there. Okay, so here it is. So what it is? So it is a system that we developed to monitor our equipments, and BP is spread across the globe. We operate in more than 100 countries, and we have equipments ranging from oil rigs to refineries to gas plants, LNG plants, solar panels, wind turbines, and everything. Okay, and we have deployed lots of IoT devices that monitor these equipments. In fact, a certain equipment might be monitored by tens or dozens of IoT devices. And we had some statistical systems that use those sensor readings to monitor those equipments. And this application is a next-gen application that we developed in the last couple of years. And it works by analyzing these IoT sensor readings to monitor various equipments and forecast or identify any unusual event to helping in predictive maintenance. So the challenges involved handling large volumes of data and forecasting based on numerous sensors for a given object. So here's a high-level architecture diagram. So I won't go much in detail into it. So it's mostly about collecting the data and then processing, and this shows like how you can scale it to global scale, serving more than 100 countries. So here are some typical challenges that we faced with time series data. So here's mostly frequency discrepancy, because the devices are not calibrated to always send their readings at particular interval. So some devices may send a reading every second, or some may in every 5 seconds. And there is also a range variability. Sometimes even a temperature sensor might have different sensitivity, and their range may vary. sometimes due to network connectivity issue or some local failure, we may have some incomplete data from these equipments, and sometimes the devices fail and new devices are installed with a different sensitivity and different operational range. So we have to account for data drift and do calibration for them. And because we are operating across the globe in 100+ countries, we have to account for large data volume and ensure that our pipeline runs in pseudo real time. And then we have to do this contextual and semantic insight, because an equipment might have multiple different sensors, and we can't just predict based on one sensor. We have to account for all the sensors to have a holistic view of the equipment. So we do a lot of feature engineering on time series data. It starts with handling missing data. So we impute missing values with techniques like forward fill, where we carry forwards past readings. We also do backward fill sometimes, and sometimes we do interpolation. It could be a regular normal linear interpolation or some complex polynomial interpolation. We also analyze the gaps and do other feature engineering techniques. We also invest time in creating custom features that help in our model's accuracy. So most of these custom features are based on normalizing data, also combining multiple tags to aggregate feature, also generating of statistical feature like rolling means, medians, variance over a specific time window. And we also try to reduce irrelevant features based on feature importance analysis. For example, there might be some sensors monitoring the equipment, but they doesn't make any sense. And we also use our SME inputs to define some domain-specific features for specific equipments, like let's say an oil tank storage or a solar panel or a wind turbine. Okay, here is a screenshot of how the system predicts and shows the alerts. So below you can see it use the reading from 4 tags, which are basically sensors, and on the top you see the anomaly score. So there is a spike over there in this start of this red rectangular area, and the x-axis is the timeline and y-axis is the prediction score. It can range from 0 to 1. So here you see an alert being notified to the end users. And the key here is we are doing this multivariate anomaly detection, because let's say we have a car and if you only monitor the speed, it may not give us a full picture. We have to monitor the speed, also the pressure on the brake, and the whatever gear it is, the slope of the surface and everything to to determine whether it's an anomalous event or not. So we mostly use graph neural network for this kind of modeling, and these graph neural networks are a specific types of neural net that operate on graph. So what we do is we translate this time series data into a graph with different types of node. So there might be one node for each timestamp for the model, and other times we can also create nodes for different collaborative features and so on. And it launched by utilizing the technique called gap attention network or GAT. And the key concept there is basically it's a more more basically evolved attention mechanism, where it is trained to learn from heterogeneous nodes in a graph, and we specifically use this multi-head attention, where each attention head can learn different relationship. It offers us a lot of flexibility, and they can adapt to different complex use cases. So we can have one family of model that can monitor oil storage tank, wind turbines, solar panels, refineries, and everything. So in fact, we have only one specific model type, and we will train them on various different equipment type. And these models have also expressiveness and interpretability, so we can explain why exactly we are saying this is an anomalous event. And so it can really help the analyst in doing the specific investigation. So how it works in basically is by capturing feature relationship, temporal dependencies, and dynamic relationship. I'll go through them one by one because I have some time now. So in feature relationship, this graph attention layer is trying to capture this relationship between different features. So where a feature could be, a reading from a sensor or some custom feature that is aggregate of multiple readings. Because anomalies in a system often involve changes in relationship between different metrics rather than a change in a single metric. So that's why this basically gives us the flexibility to explain why we see it is an anomalous event, because you can explain this difference between the observed matrices, and it can also help us in modeling temporal dependencies. So in time dimension, it can keep monitoring and find an anomalous behavior, because this temporal context of data is very vital for understanding in anomalies, because something that is sorry, never ever been seen before is most likely to be an anomalous event. And these GATs can also learn dynamic relationship between different time series values. So here is a link to the paper if you want to learn more about this. So next step. So now with emergence of these generative AI techniques, we have also seen emergence of time series foundational models that can perform this time series analysis out of the box. So we have tried all of this, like Times FM from Google, which is a univariate model, also Moirai from Salesforce, which is a multivariate model. So these models can detect anomalies on existing data, also from streaming data. There are models like Moment who helps in forecasting. Okay. I think the mic is on. Okay. So what I'm seeing now is with this model like DeepSeek R1 and GPT-O3, we have this deep reasoning capability. So we can basically send the observations to the models, and we can help it explain like whether there is an anomaly or not. So thanks all for your time. Thank you.
Yeah, you can clap. That's not. Okay, while the screen is coming up, just wanted to reiterate or summarize what we heard is about Defense in Depth by Shitanshuji and Vishal first. And then like we spoke about the coil surface temperature, which is picked up in near real time probably from the DCS, and using machine learning for enhancing the coker efficiency and reducing the picking times. There's a second thing which we heard. I'm just trying to fill in organizers and the AV team because the screen is not up. So I'm just trying to fill in. Okay, now after that, like you should not say that like, okay, get on. And the third thing is what we heard from Subhendu is about combat challenges with time series data and leverage GAT. Graph attention networks in multivariant models. That's what we have heard. So these are three different things. With me, as I told, like a few of you walked in between. I work with Accenture as Managing Director leading energy practice globally for the strategy and consulting. With me, I have a couple of colleagues, Debashish and Tarun. So they both are sitting here. But the reason why I'm talking about this is I have one another colleague in this room. His name is Rabi Narayan Mishra, who is in the data and AI practice. And Karthik, I'm coming to you. So the reason why I'm talking about Rabi Narayan Mishra is we used to, we all here, right? Like today is not a Friday, so but still I can talk about it. We all know serial killers. We all know serial lovers. And this guy, Rabi Narayan Mishra, even if you look at him, you'll figure out, Ravi, if you want to stand up, people are trying to look for you. So people call him a serial inventor. Okay, so he has patents and he has a lot of inventions and he's part of innovation team. And Rabi, today you have a competition on the dais. Karthik, who's sitting silently on that side, is an equally strong serial inventor, working in MRPL. He's a senior manager out there, and he has used the best of the best machine learning and AI, and has been on the inventing spree. It's pretty interesting to note that he has 6 patents granted on his name. Big round of applause for that. And he has several international publications, 7 publications he has done. And more than this, so his total work ex is 16 years. And in 16 years, 6 patents is not a small joke. And on top of it, there are 14 in progress. So I think I'm going to be subscribing to you if you have any of the channels, Instagram handles, LinkedIn and all that stuff. It's very interesting. And now what he's going to talk about is the 4 years of experience building and deploying real-time optimizers for the hydrocarbon industry, which has won the Best Innovation in Refinery Award from Ministry of Petroleum and Natural Gas. That's what Karthik is all about. Karthik, over to you for the next 15 minutes. Thanks, AV team, for bringing up the screens.
Thank you to the chair for that fantastic introduction. I hope I disown all those nice words you have actually said about myself. And it is teamwork, though actually all those laurels what Sarah said, including those 4 years work, awards and the patents. I mean, I'm one of them. There is good amount of teamwork involved. Thank you. Anyways, so coming back to the topic. So for the last actually 4 or 5 years, we are in the process of building our own patented algorithms to make actually real-time optimizers for process units. So you may be, most of you who are from a refinery background must be already aware that there are quite a good amount of commercial softwares which are available in the market, which can do real-time optimizers and which have been even deployed for actually decades in the industry. So I am just trying to actually take you through what are the pros and cons and why we got into building those machine learning models to employ in RTO or real-time optimizers, and what is our actually experience so far. So just for actually general understanding, when we say first principle and AI model hybrid, what do we mean by actually first principle? Specific to a refinery process unit or a petrochemical unit context, the reaction kinetics or the yield is basically predicted from, as most of you may be knowing, the first principle kinetic models. So these models often involve thermodynamics or the kinetics or a combination of both to predict the reaction yield as well as the properties of the streams. So the challenge today is you actually need a good amount of research and development work to develop a kinetic model which best fits especially a commercial plant. Often most of the literature available are specific to a academic work. So most often than not, they may not be applicable to a commercial setting. And if somebody is to develop a kinetic model which works for a refinery sort of commercial process plant, we need to at least spend a year's job in the pilot or a demo plant, try to mimic the lot of non-idealities that creep in a commercial reactor. So most commercial industries like a refinery like us or most of the industries often depend on licensors or third-party softwares or the catalyst vendors to develop these models and deploy. And of course, there is a commercial implication to that. So this specifically a background on what is a kinetic first principle model is. And then there are good amount of AI actually algorithms which every month it is keep on propping up, and you have heard certain algorithms before from my fellow speakers on the stage already. So I won't dwell into actually the details of the different classes of algorithms and what they do. But what is their advantages? They are sophisticated, they are superior. Industries like us often have a rich history of good amount of process data history. We have every year actually GBs and GBs of data generated based on our unit operation, and this data can be leveraged to develop models. But what is the disadvantage, or where do they actually fall short of is they often handicapped when you go for a new operating envelope, or when you go for, especially for a catalytic unit, a different catalyst whose mode of operation or the yield characteristics itself differs from the previous history. So they often predict wrongly here and they fall short here. And of course, this is a primary reason why they often are prone to false prediction. In fact, there are certain actually technical nitty-gritties to it, which I will cover in the subsequent slides. Prior to getting into how this fit in the global scheme of real-time optimizers, what we call this as, what you see in the slide, is often called as actually a pyramid, process optimization pyramid in the industry. It is of course from an open source database from hydroprocessing literature. So the gist of this pyramid is the economics, how it actually drill down, or how it is supposed to ideally drill down to your day-to-day operations. At first, at a broad level or enterprise level, there is a production planning, which of course there is involving a set of actually prices of your crude, prices of your product, your operational constraints, availability constraints. Often this is being carried out actually months to weeks domain. And this is actually involving third-party softwares like your Aspen PIMS, or most industry have actually even Honeywell solution, or most of the third-party solution. A point to note here is this is completely driven by economics. Subject to your constraints, what is the best way to do in order to maximize the margin. So ideally, our day-to-day operations, including our regular shift operations, should fall within this scheme of things. It should strive to meet your global plan. But most often not, this doesn't happen. I will explain why when you actually break it down. So from planning, we break it down to actually day-to-day actually scheduling. Most industries often again have a mixed integer nonlinear programming based scheduling tools like production scheduler of Honeywell, or even multi-blend optimizers. Once scheduling is done, even the recipe of blending is optimized using MBO sort of third-party software. But here also a point to note here is some amount of economics is involved when the plan is broken to a granularity of weeks and is passed to your operations. The next level, what is supposed to be there is, from the scheduling which had economics, you are supposed to have a real-time optimization which takes care of a hours to schedule. Hours of that schedule, when you implement for a shift, you are supposed to run the unit, like say for example, if it is a FCC or a hydrocracker, that unit is supposed to operate for a shift in order to maximize that shift margin. So there is a big gap here. This is what I want to actually tell you earlier. Why it is? Because first of all, this is easy for a unit like crude distillation unit, and most third-party softwares today have a lot of commercial experience for crude distillation unit. It's pretty much straightforward. There is no variability there. Once you know the distillation, mass transfer, and the thermodynamics, this is going to be easy to implement in a shift horizon. For a catalytic unit, this is very, very difficult. Why? Because first of all, for a catalytic unit, in a real-time operation, the catalyst changes, especially unit like FCC. The inventory of catalyst, especially every 2 to 3 months, the recipe changes, the people who supply the catalyst changes. So every shift wise, the inventory of FCC catalyst changes. So what happens? Your operating envelope also has to change depending on, for that catalyst, what is the best yield. So there are third-party softwares which predict the FCC yield specific to FCC, but the challenge is you need a vast actually laboratory data. You need to do feed fingerprint, which needs HPLC, NMR. When we estimated about 4 lakhs or to 5 lakhs actually worth of laboratory analysis in terms of rupees you have to carry out to one time calibrate your model for a kinetic model. And often the data operating envelope will drift. You calibrate a FCC model from a third-party software, it will be valid only for that local actually envelope for operation. If you increase your ROT, if you change your recycle ratio, you have to again recalibrate your model. So after a horizon of say maximum a month, the model has to be recalibrated, and practically when we look at every 2 weeks once you have to do that. And once this sort of laborious activities involved, people don't maintain this. So mostly, though people deploy this sort of third-party solution, it doesn't work in the field, and after a month or so, people actually stop using this. So this is the biggest challenge with the kinetic model-based third-party software of RTO. So of course, we have APCs and basic process control system with which people are already aware of. I don't want to go into the details of it. So based on this background, we have built actually real-time optimizers for multiple units. First of it is a power plant. Power plant, it is pretty straightforward. Why? Because there is no kinetics involved here. It's only thermodynamics. What is our uniqueness is, as I said earlier, there is a combination of not only first principles, also AI. So let us say you have multiple actually steam turbines or gas turbines. Theoretically, steam turbines follow, say, actually a modified Rankine cycle, and gas turbines follow Brayton cycle. So ideally, all of this machine, if you buy from the same OEM, are supposed to be giving you the same efficiency, right? But we know that practically in a plant, it doesn't follow that way. The same OEM, the same actually sort of machine, but the power extraction as well as the steam generation from different machine used to be at different cost of production and different efficiencies. This is because inherently the machine has some non-LLT in terms of the valves, in terms of the workmanship of the turbines, etc. So what do? Is we use the actually first principle based, actually this modified Rankine cycle or the Brayton cycle based. The models are there, but it is also actually hybridized with the first principle models, sorry, the AI models. So this is a big area by itself. The hybrid models, it's along with first principles, you can do in a parallel mode, you can do a series mode, you can do in a first parallel plus a series mode. So the big research actually got into it, which configuration is optimal based on which we have deployed, and it is more than 4 years it's working. The beauty of it, which normally you don't have in a third-party software, is we explain why actually a specific combination of machine is preferred. Also, when you actually import a power from a third party or from grid, so what is the economics, how to load this machine in such a way that you minimize your cost of actually generation, you maximize your profit. So it gives you insight. See, the main point here is the operator needs to be convinced. Historically, he has a mindset that this machine is better than that machine. But often he may look at only one point of view in terms of, say, a particular steam or power. What is the fuel being involved? Probably that machine is efficient in terms of energy, but the fuel is costly. So in refinery, you have actually, say, a fuel gas, natural gas, or naphtha, diesel, everything to run a machine, right? So what is the actually fuel you use to generate also matters here. So this dynamically in real time, it gives every shift wise what should be the machine done, operated, and what is the cost of generation, etc. And it has been used to operate that way. I'm sorry, it's not working. Yeah. The second one is polypropylene unit. So this is a solid unit. So what happens is people every 2 to 4 hours they take a sample and then they analyze melt flow index or xylene solubility, come back and adjust the operation parameters. So real time we have developed the soft sensors for predicting the key parameters of melt flow index and xylene solubility. So people don't wait to laboratory analysis to optimize the parameters of the reactor. So the best advantage of this is if it has gone off spec, about 6 to 8 hours is spent in making a off-grade material, which is a value loss. Here we are actually indicating the properties real time, where real time action is being taken to control the polymer characteristics. The best part about is we have reduced our grade transition period from 8 hours, it has come back to 4 hours, and we also reduced our laboratory analysis of the reactor parameters also. So it is now actually every 4 hours once, that too to train the model to see how the model is performing in retrospection, we do a laboratory analysis. So this is the second part what we have did, and this is the level of actually prediction versus accuracy if you are interested. And the most important part is for FCC unit. Here I just want to touch again what I was saying earlier. See, when we do actually a machine learning model, I mean what's the difference between a core guy developing a hybrid model and a ML guy or say AI guy doing the activities? They don't know the intricacies of the deployment or where it will fail in the deployment. I will tell you something. The model, when you use a AI model to predict, there are a good amount of algorithms. I am sure about n number of algorithms, more than 10 or 20 algorithms. When you train on the data, it will appear fantastic. Prediction accuracy will be too good. What is the actually intricacy here is, there is something called what we call it as input dependency as well as output dependency or a variation. For the same set of input parameters, your yield will vary. For specific to FCC, your actually riser outer temperature or the recycles or the steam injection, you will have historically say actually 30 or 40 data, the data being the same, but the yield prediction will vary. This what we call it as input variation or input actually dependency. The other way around it also happens. For the same output data, you will have n number of input parameters. Why it happens? Again, it is actually got to do multiple actually theoretical background. I don't want to go into it. So AI model often fails to this. And there is something also called as actually a path function of the kinetics. So when you increase the ROT, let us say from 525 degree and go to 545, you observe a trend in increase of say propylene. You come back the same actually 5 degree variation, come back from 545 or 565 to 525, the yield variation will not be the same. It's like path function in thermodynamics, point function versus path function. So the path traveled for the same parameter variation from top to bottom and bottom to top is different. First principle models will be able to capturing that. So with this, we have developed and deployed first principle model in closed loop. To the best of my knowledge, nobody in India has did this already, or arguably in the world. So this is actually advising our operators in real time. This is a DCS screenshot of the system we developed and deployed. So based on this, we were able to save about 100 crores to FCC unit, and we are still progressing and implementing across the refinery the whole thing. And this has got 2 awards in the last actually 3 years from Government of India for best innovation in the refinery. So thank you very much. Thank you, sir.